The crankshaft that we've got set up here between centres with the dial gauges on it is for a Royal Enfield Model G, which out of all the Asbo bikes I've only done one of this kind before, and that was actually one of the Model G's predecessors, the Model CO, although I think it was a mixture of CO and G parts, and it was Asbo number 28, and I referred to it as the G Whiz. Well, this is Asbo 39, and I guess it's going to be the G Whiz too. And I've split the flywheels and I've lightened them in the usual manner, or the same manner as I did as the last set like this, which actually meant I took very nearly a kilogram off each flywheel for this type. So we got nearly 2 kilograms reduction of weight overall on this, which is more than I normally take off for later type Bullet 500s and even the later type 350s when I lighten them. But here we are, we got it in between centres again, and as usual this clock reads in thousandths of an inch, so the 0 to the 5 is 5 thousandths of an inch. This clock reads in tenths of a millimetre, so the 0 to the 10 is actually 0.1 of a millimetre, or 4 thousandths of an inch. We've got 5 thousandths of an inch there, so they're very similar as I've said in previous videos. Let's take it round to the point. There you are, both clocks needles are on the zeros there, and if I rotate the crank, you'll see as I rotate it that there is movement in the needles on the clock faces, but they move in the same direction at pretty much the same time. So I'm seeing perhaps 3 thousandths of an inch run out on this shaft here, and actually probably about 3 thousandths of an inch there, because from the 0 to the next number would be 4 thousandths of an inch. It's not that much, so it's about 3 thousandths of an inch there, 3 thousandths of an inch there. They're moving in the same direction at the same time, so effectively when those shafts are in the main bearings, those runouts there will become zero, and any movement, slight movement, will be transferred to the extreme ends of the shafts and perhaps back to the flywheels a little, but that 3 thousandths of an inch run out, if you want to call it run out, will be halved by the time it's shared between the ends of the shafts and the flywheels. So the maximum run out that will be anywhere would be 1.5 thousandths of an inch, and there'll be effectively no run out or zero run out at the main bearings. So I'm very unlikely to get better than that. So what I'm going to do with that is I've got this crank pin nut tightened up. There's no locking screw in there because the threads in the flywheel were stripped, so I've used a thread locking compound on the nut. This nut here is done up tightly, the threads are okay for the locking screw, so I'll get it out the lathe now and put the locking screw in, and this crankshaft will be ready to go in the engine. So there we are. I'm very happy with that, and I've got to weigh it yet as well, but I think overall it's probably going to be around about, not far off, 2 kilograms lighter than a standard Model G crankshaft, so that should liven the engine up a little bit as well. This is the bottom end of the engine that will be, well, it will become Asbo number 39 and or the G Whiz 2. It's a Royal Enfield Model G obviously, and we've already seen the crankshaft in the lathe between centres being checked for run out, and it clocked 3 thousandths of an inch at the same point of rotation on each main shaft, and I've already explained that the one effectively cancels the other one out. I've got the crankcases clamped together now with all the bearings present. Admittedly they're not the new bearings yet, but there's no real sort of wear or damage to them, and they will be renewed, but I've just put it together for now. So we've got 2 roller races on the drive side in there, and 1 roller race in the timing side in there, and just to demonstrate it all spins freely in the main bearings, I can push this conrod down, let go, comes back, push it down, let go, comes back. rotates right round easily enough. See that there, nice and easy. But also I'll be shimming. There's a little bit of crankshaft end float here, which when I do the final build with the new main bearings and everything, I'll shim that. But for now, the end float's a good thing to have to demonstrate that the crank is free, not binding in any of the main bearings at any point of its rotation. Getting near the bottom dead centre there. I'm still able to slide it from side to side, going past bottom dead centre and coming back up. At each and every point of rotation there, I can slide the crank side to side because of that end float. So at no point is the crank grabbing or binding in those main bearings. So it's nice and free all the way round. So that's going to give the bottom end hopefully a long and happy life, and allow the maximum power produced between the piston and crankshaft to get through to the next stage, the clutch, and then the gearbox, and then the rear wheel. So I'm very happy with that, and I'm going to organise some new main bearings for it and put it together for keeps hopefully.